Hello everyone, I am Nadine, and today we're going to learn how to build an attention checker. So basically, during the time of the COVID, we are either working from home or attending lectures from home, or even studying or working, and we're always getting distracted by external stuff, and then we lose focus. So today we're gonna learn how to build an attention checker using the Google AIY Vision Kit, which will alert you if you lost focus or if you're not concentrated or distracted by external stuff. So let's start. So before starting, let me tell you more about the assembly. So basically the assembly is a smart lab. It's based out in N5. And we have done over 250 free workshops since December 2014. The workshops includes 3 different categories. We have the hack category, which is the hardware, the embedded systems that includes the IoT as well. We have the code category, which includes the software projects, the APIs, and the framework and the apps. And we have a more advanced topic related part, which is the data science. That includes AI and machine learning. And today's workshop, it falls under the data science, of course. So our targeted audience are students and professionals and entrepreneurs, but everyone who's interested is welcome to attend our workshops. So we focus on smart technology and practical applications. And also there is a forum. If you would like to know more about the assembly, you could go there and learn more. You could even tag us and find us on all of our social media. We have the Facebook and Twitter and Instagram and YouTube as well. So let's start with the workshop. So an overview of the workshop today, we will learn how to use we will learn more about the AIY Google Vision Kit, the Google AIY components, and what is the use of the components, and what is the exact use of the Vision Kit, and the APIs that are offered, and even that design that we are going to build for our attention checker. So to start with, what is the AIY? Basically, it was an idea from Google, and they've been working on creating an on-device neural network that could be ran on the device without any power being provided from the cloud, without any cloud connection. So it's an on-device neural network. And the main component of the Google AIY is the Vision Bonnet board, and it's powered by the Raspberry Pi. So we have the Raspberry Pi and the Vision Bonnet board, and both of them forms the whole Google Vision Kit. The Bonnet features the Intel processor, which enables the board to actually run the neural networks on the device without any need to the cloud connection. So the components of the Vision Kit, it has several things. It doesn't come with the Raspberry Pi Zero, but you have to get the Raspberry Pi Zero and connect it to the AIY, and you have to have an SD card, of course. And the Vision Bonnet itself, a board, is connected to the Raspberry Pi throughout all the GPIO pins that are there. And they have also a camera that comes with the Vision Kit. And also there is an arcade button which blinks and changes colors and stuff like that. There's also an LED, and there's a buzzer, and there are some other supporting components that just helps in assembling the whole thing. So the Vision, why should we use the Google AIY Vision Kit? So basically it offers us a variety of functions and services. So this kit, it has already some pre-trained models. It has 3 TensorFlow-based pre-trained models. So we have a model that classifies the images, and it could just capture image and classify around hundreds of categories. Also, there is another model, which is the face and joy detection. The face and joy detection is just detecting the face and showing the percentage of the joy of your emotions. There's also another model, which is only detecting 3 things. Either you're a person, a cat, or a dog. So it's just classifying those 3 categories. So you can also create other customized TensorFlows using TensorFlow models on the Vision Kit, but then they have to be a specific type of models. They have to be either MobileNet V1 or MobileNet V1 plus SSD or SqueezeNet. So, and you could even train your TensorFlow models using this Vision Kit. So today we're going to use the models that are actually pre-trained and are actually there on the AI Vision Kit. So also, the AIY, it has a very good thing because it offers us some Python APIs that we could use that will ease the process of like controlling for example, the buzzer and the arcade button and the LED. So you could change the RGB button colors. You could adjust the buzzer sound. You could access, even there are 4 GPIOs pins where you can access and do some stuff on them. So the libraries that we will be like, those are all the libraries that the Python API, that the AIY Python API offers. We have the tone player, the track player. Those of course are related to the buzzer. We have the annotator, and this is related to the camera, the inference, and we have the models, and this where all the models are there. There is also the board. This controls like the chip itself, and then the LEDs, the LEDs, which controls the arcade button or the LED on the arcade button. And there's also the pins. So how is our design for the attention checker? So basically this is really up to you, but this is like the design I chose. You guys can like, of course, change the timing or even like change the arrangement or things, but this is my design. So the design for the attention checker today is going to be, at the beginning, you will enter the study time or the time you want to focus in. And then before like starting the attention checker, it has to first detect a face. So it will keep detecting for 2 seconds because it will take the average because of course of the accuracy. And then if it detected a face in 2 seconds, it will then check and go for the next step. If no, then error message and just end the program. So then after that, you will start checking, is the duration over or not? So of course, you entered the time that you want to focus on. We will check whether like this time is over or not. And if it's not, you will go inside the loop and start actually like checking for other stuff. So the attention checker that we are doing today basically focuses on 2 main things. We will use 2 models. We'll use the face detection model and the image detection. The face detection model, it will just like detect whether your face is there or not. And accordingly, it will report that you're not focusing. And for the image detection, it will detect if you used your phone, then it will also report that you are not focusing. So it will, like for my design, I will be like waiting, I will be checking every 5 seconds and then alternating between the phases. So the first 5 seconds, I will wait first 5 seconds and then check for the phone for like 2 seconds and take average. And if at least one of them is like you are using the phone in at least one of them, then it will print an alert and light the LED and even play a buzzer. And that will be the exact same thing for the face. But then I have done it like it's 5 seconds and then check for the phone and then another 5 seconds and then check for the face. And then it keeps repeating until the time is over. And if the time is over, until like when the time is all done, it will print like a congratulations message and it will play a victory song. And then at the end, it will show you the effective study time, like a summary of how much time you wasted using your phone, how much time you wasted, your face is not there and stuff like that. So that's how it looks from the inside. As you can see, this is the blue board. This is the AIY board that we're talking about. And then like in the bottom, it's not appearing here, but in the bottom, there is the Raspberry Pi connected to the AIY. And then we have also the camera over there, the green one. And then we have the arcade button, which is like it can do both. Like you can press it and actually it can light and change its color. And also this is the buzzer, as you can see. And we're connecting it using the HDMI. And also there's the other one, the blue one. This is the power connection. So let's start coding our attention checker. So the first thing that we need to do is just write the import statements. So I'll just copy paste it from the code that I've previously done, and then I'll just explain each import statement, which library it will be doing. So yeah, here it is. So first we'll have the artparse, which is the library for just parsing the data from the command line. And then we'll have the time, which will be like detecting the time that is like the current time, getting the current time. We'll have the Pi camera, and then we will import from it the Pi camera and the color if you are going to like annotate the text on the camera itself. Also from, this is all like from the Python and from the Pi, but then for the AIY APIs, those are all the APIs that we're going to be using. They're actually there on the board, but then we need to import some specific stuff for our program. So the first thing we will import from the inference, the camera inference, because of course we need to use the camera. Also, we'll for the models, we need to import like both models, the face detection and the image classification one. Okay. And then we can import the annotator, but like it's not that we're not going to use it that much, because if you like use the annotator for like continuous classification, it doesn't close well, and it just like takes a lot of resources, and then it might just crash your board. So it's better not to use the annotator. And then we have the LEDs, which just controls the arcade button colors, and yeah, that's just the arcade button colors. Also, we have the board one, and that's like controlling the board itself. And then we will use the tone player and the track player to play like the victory song and then the alert. So let's start first by like, we want to take the time when the user starts and enters the program. So first we'll have like the text, and that will just take the time, .time from the library of the time, sorry, no. So yeah, that's the first part. We'll just take the time. Also, I will do all the initializations over here. So first, for playing any track or playing any tone on using the API, we need first to initialize a loader, and then we put that loader into a player, and then we play using the player, use the function play. So the first thing is I'm going to create an alert loader. Okay, so that will just take the track. There's an object called track loader, and then this track loader will take first the pin that we want, and like the GPIO pin that we are using to connect the buzzer. And in the AIY, it's a default one, which is 22. And then we pass it the track that we want to play, and it's just the file name. So in our case, there are like other tracks that already come with the AIY, and even you can like find some stuff on GitHub. It will be there also in the description. So there is a track that it's there, which is called like sad trumble, and it's just like a buzzer thingy. That's an alert one. So I thought that would be suitable for the alert. So I'll just use this one. So it's trombone.track, and just make sure that it's saved on the same folder that it's there. Also, I will create another loader for the congratulation song. So I'll just call it congrat loader. And then this will be for the track that is the track for the congratulating song at the end. And it will be also to the same pin because it's the same buzzer, and just the track is different. So its name is congratulations, I think, .track. That's the track that I have. I have it stored there. Okay. So that's the first thing. So the second thing is we need to create the player. So we'll have the alert player, and then the player just takes the track loader. So it will be alert loader, and then it just takes load. Okay, so that's the function that loads it inside the player. And then I'll have another one for the congratulate player. It's the same congrat player, and it's just equals to cong loader dot load. So now we have all the loading and the players and everything set up there. We'll just use it down there when we reach to that point. Also, we'll need another function that like updates us whether the time is over or not. So it's easier to create it just a function. So a function that just returns a Boolean, and I'll just call it duration over, for example. Okay, and then we'll just have it this way. So maybe if we want to make it more flexible, we can be taking input from the user. That's what we want. So they can like enter the study time. So we'll just like initialize the thing by like, for example, saying time start, maybe we can call it start is equals to X. And then that's like the time that we want to set. And then we will save the current time. Like each time you enter, you will save the current time, and then just like subtracting both, and you will get whether the time is over or not. So of course, the thing that you need to take care of is that we need first to make sure that we enter, when we pass this x, that it's in seconds, because this one passes the things in seconds. So let's just have an if statement. So if, for example, x, or you can just like use the x directly, just like if the current time minus x. And yeah, and then just we will return true if it's less than x. Oh, we need to save the start, I'm sorry. So we'll just this minus the text that we have inputted from the beginning. So we will just like check the current time, check the time that he have entered, like the whole thing from the beginning, and compare it with x or with the start. And then we either return true or return false or whatsoever. So we'll return true as long as it's less, otherwise return false. So now we have done the function for the duration. So just this need to be captured. So yeah, so now it will just like take the current time and then return true or false according to whether the time is over or not. So now after that, we need, as we said, we need to use like the two models. We need to use the face detection and the image detection. So what we can do is that we could start first by the image detection part. So because like before, if you like, there are like the existing models, you can just like write the code for the face detection directly in the main, but here it won't be efficient. So it's better if we created separate functions for the face and for the image detection. So I'll start first by doing the face detection. So I'll just call it face detection. I can't call it face detection because that's the model name. So I'll just call it face detection inference, for example. Okay. And then I'll have this. This will need to take a camera, okay, a camera object, which we will be passing like from the pi camera that we will create in the main. And then it will need to take as well some parsed stuff from the input. If it doesn't enter a parse, if the user didn't input like specific frames or specific things, it will just set some default values. That will be done in the main as well. So to start with, we need first to create a camera inference. So it's called camera inference. And then the camera inference, it's better if you used with when you're doing the camera inference, because like this is more cleaner. It will just open and close everything. You don't need like to worry about like closing the resources. It will just like free up all the resources. So we'll just like use with, and then we will pass the inference, the model that we want to run. So here we want to run the face detection model, but then we have to write face detection and then dot model to get the model that we want. So it's like a function, okay? And then after that, we'll say like this inference, we'll call it inference, for example, inference, okay. So yeah, that's better. And then inside the camera inference, now we created the camera and then we passed it the model. We need to get the data from that. So first, the best thing is like we said at the beginning that we will have the camera not running like all the time. We'll have it just like running for 2 seconds or something, and then it will just stop. So I need to set a timer or something for that camera. So I will just get time.time from here. So I'll get the current time when you directly enter the face detection inference function, you'll capture the time and then you'll just keep looping until the time is less than 2 seconds. When it's more than 2 seconds, then I'll just exit the loop. So I will start now I created the inference and then I need to to get the result of the camera and then pass it to the model and then start getting the output. So to do that, the first thing is we need to run the inference that we did. So I'll just it's better to do it as a for loop since we don't know the number of frames that we have. And since we're still having results, so it's better to have it as a for loop. So the for loop will have maybe a variable called the result that will just take the inference dot run output. And then for the inference dot run, we just need to pass it first the camera. No, we need to pass it the arg as, what did I call it? Yeah, dot the num frame. Okay, so you can do that. We will do that like in the main, and yeah, we'll just like adjust like some specific frames. So either like you can assign it a specific frame, or if you didn't assign it, it'll just like run infinitely. Okay, so yeah, now we have the for loop that will just capture the results from the inference. So I then need to pass this thing. It's like when you do it in the inference, it's passed to the model, but then you need to like capture the data, like capture the output. So we can capture the output using this function. We will say phase detection inference. So we'll use the phase detection, and then there is a function that is there offered in the API. It's called get faces. Okay. So it will be this way. So you will just pass it here, the results that you got from the inference. So it will be the result. And then you can store this into something, maybe like call it faces. Let's call it faces. So here we will get the faces, okay? And then just store it in another one called faces with all like the array of faces that are there, okay? So the first thing is we can do separate things with that. We can print on the camera itself, the annotator, we can print on the screen. So I will first print on the command line. So we could like print, we could print like several stuff. We could print the count, we could print, so first we can print the inference count. So we can like say string and then inference dot count. There's something called count where you can like get the count. And yeah, and after that, maybe we could like, I don't know, we could like print, even the length of the array. So as I said, faces is just an array of like the faces that are there. So we could just like print them over here. And yeah. So yeah, that's basically it. And then this will be just like printing on the screen, something like count number, blah, blah, blah. This is the number of faces that are detected. Okay. So after that, we'll just like move to the part. So now we have the faces, we have the number of faces, but then we need to do like our processing on that. So we could like add more fancy stuff. Maybe like we can annotate those text on the camera itself. There is this function called camera dot annotate. Yeah, and then we could just like annotate any kind of text that we want. Okay. So after that, we need to do like our processing thingy. So the only thing that we want to do is that we need to check if the length of the faces are more than 1 or not more than 1, no more than 0, then that will be our case. Then there is a face detected. So we'll just like return true. If there is nothing, if there is like less than 0, or 0 actually, so it will not do anything. So just here we'll need to like check if it's bigger than 0, then we'll just return true. And yeah, that's it. And then otherwise we'll just return false. So yeah, so that's basically it. The thing is now that this is just what we want. We want to return, if there is a face detected, we'll return true, at least one face detected, and then otherwise it will return false. But the thing is, this loop keeps like repeating forever if like there is no specific number of frames passed. So what we can do is we did that because we want it to be only 2 seconds. So what we can do is that we can create an if statement that just checks the current time. So maybe we can have another one that is time.time or something. That's fine. We can just put it here. So yes, we just get like this time current and then just call it this way. And then we can say if the cam time minus the current, or just the current minus the cam is less than 2. Sorry, if it's greater than 2, we'll just break. So if it reached this point, we know that it didn't detect any face. If it has detected in any previous loops, it would have returned true. So if it reached to this point, then just return false. So this return false here shouldn't be at this point, because this will return at the loop. This should be here. And yeah, so that's basically it. It's just we did everything, and we are just going to loop until there are 2 seconds remaining. Yeah, and then it will return false if it didn't detect any face within the 2 seconds. Otherwise, it will return true. So yeah, let me show you on the AIY kit now how this code works. Okay, so let me now show you the face detection. So first, the models are all saved on a specific directory over here. So this is the directory that all the models are like saved on the AIY usually. So it's the AIY project, Python source, example, and Vision. So if you do an ls here, you will find like there is the face detection camera over here. So that's the one that we will be trying. Also, there is like the image detection is here as well, the image classification. So yeah, let's try first the face detection over here, and then the other parts will come in the code when we comment in the code. So what we do is just like a dot and then backslash, and then we just write the name of the model that we want to run. So it's the face detection model camera. That's the one that we want to run. And then yes, it takes some time to open. So let's just wait. So of course, this one comes with like several models. Yeah, now it's open. So yeah, if you can see me, that's me. Then it just takes some time to get initialized. So now you can see it's pointing on my face. And then if you can see the screen, it's a bit hard because like output's not there. But if you like saw the command line, it's displaying the number of faces that are actually detected. Now we have seen how the face detection works. Let's go to the image detection. So it will be exactly the same. It will be another function that also takes the camera, and then it will like detect the face and everything, and detect the image and everything. So to start with, we'll just like start by the same thing. We'll have definition, and then we'll start by we'll call it like image classification or something. _ inference. Okay, so yeah, and then we'll pass it the camera as well, but then another parse, I'll call it just arg, or it doesn't matter honestly. Yeah, and then inside it we can like literally copy paste the same exact code from here. Just will change like several stuff. So until here it's the exact same code. So just to save time, so rather than here face detection, it's called image classification in our case. And I'll just like go with that model. That will be our model for that part. And then here we will just run the same thing. And then, yeah, and then the results and everything is the same. So yeah, that part is exactly the same. But then here, when we are getting the output from the image classification in Inference, we need to use other functions. So first, for the image classification, we need to get classes, because actually, like the output for this one is like a pair with the first part of the pair is the classification, or like a string with the class, and then the other part is the threshold. So there is a function that we like we could use it to join everything and just return to us the classes. So what we can do is okay, let me just get that function. I've wrote that code before. Even it's there on the image classification thingy. Like if you have the image classification thingy on your AIY, you can just literally get the same function from there. So it's just like the class info thingy. So all it do is just like it prints everything in a neater way. It have them as a string in a neater way, with first the category or the class name and then the threshold of that class. So as I was saying, we need first to get the data for that part. So we will store it maybe in something called classes or something. And then just inside this one, we will have the image classification, which is the model name. And then to get the classes, it's just get class, literally. It's not that like complicated thing. And then we will pass it as well, the ARES dot. So to get the classes, we can pass it several things. We can pass it first the result, which is the result of the run, the inference run. So it could be like passed to the model. And then we can pass it also the number of objects that we want to detect if the user like tried to input a specific stuff. So we could just like have it num underscore. So it will be the ARGS, and then we will take the specific part for the number of objects. That I will specify exactly in the main, okay? So yeah, that's basically for the image detection. And then you can do some kind of printing over here, like printing the stuff that you want. But yeah, you can like just print the classes that you want, and you can like do like you have got detected or something. So you can print the class info, since we said that this function returns the info of the class, and then we'll just pass it the classes that we want. The classes. Okay. So now, yes, that's the classes. And yeah, after that, we'll just do so yeah, we now have the classes. We just need like to split the pairs, because as I was telling you, it comes in pair, and the pair, like the first part is just the class name, and the second part is a threshold. So the first part is string, the second part is like double or float. Okay, so first we need to take each pair of those and like do our operation on it, or like check for the cell phone thingy. So first we need to create a loop, okay, for the pairs. Like this will be from inside classes. And then we can store the pair inside an X and Y, and this will store like the first value of the pair in X and the second value of the pair in Y. And then we need to start now checking if that pair is contains like X, contains the category of the phone or not. So after like doing a lot of tests, of course it's not that accurate, so you have to like input several categories so it could detect it. So after like doing all the test thingy, I've came up with that. So those are like the categories that it could detect a phone. So it could detect it as a iPod, as a micro computer. It could detect it like as several like other several stuff. So yeah. So yeah, that's basically it. So I'll just take that long if statement from here and tell you like the specific, yes. So it detected it as iPod when I was trying, and then it detected it as a laptop, and it detected it as a notebook computer. And there's also another category, like this should be like the specific one, which is the cellular phone and the mobile phone category, and then the handheld computer. So I just added everything for it to be like to capture anything. Because it doesn't have like a high accuracy. So yeah, and then yeah, just we will print that we found the phone. If we did all like this if statement and we found something, we'll just print that we found the phone and just return true. So if we found at least one time a phone, we'll just like return true and say we found the phone. So yeah, that's basically it. And then inside that, we just like say if the classes are yeah. So now here we did everything. We can like do the print as well. So we can do the print anywhere here. Maybe we can do the print like in each pair, so we could like check if or we could just like print it over here. So if classes is not empty, you could just like print the value of the. So we can even like annotate the camera as well as we did up there, and just like type the output on the camera annotator. So same, we'll use the same function. It will be camera dot annotate underscore text. Yes. And then we'll just pass it whatever we want. So we can just pass it X or something. Sorry. And yeah. And then if you, here it will be, if you didn't detect any phone for like the 2 seconds, you just return false that you didn't detect any phone. And then we just like put here for just in case the return false thingy. So yeah, so that's the image classification part. So yeah, now let's run the image classification. So we'll just do it this way, image classification, then dot py. No, we need the camera. We need the camera one. So just camera and then dot py. Yeah. It will take some time to run. Of course, as I was just saying, it's not like 100% accurate, so it will detect some stuff. And yeah, here it is. So as you can see, it's up there. It can detect, like this is the pencil. I don't know. It's not detecting. It's detecting me as an umbrella. Yeah, it's sunglasses. There is some hair dryer. There is phone. It's gonna take a lot of time to like detect it. But yeah, you can say because like there are a lot of things in the background, so that's why it's like not accurate 100%. So yeah, it's like detecting the shirt and it's detecting, yeah. So that's basically it. Let's move to the main and let's like type the main program. So the first thing that we will do, we can have something that just doesn't enable the board except when you like click on the arcade button that is provided there. So we can just like click on the button to enable. And yeah, and then you just start. So now we need to identify our arcade button. So first we'll use the width again because like it just clears everything up. And then we will need to classify the board, which the action will be taken upon it, that it will like not work except when the button is pressed. And then just we will use it this way, and then as board we can call it this way, and then just inside it we will say that the board will not be operating until it will wait for a press. So that's exactly the function. It will be just board dot button, and then it will be wait for, that's the name of the function, press. Okay, so that just waits for a press and doesn't do anything except when there is a press. And then we can print that it's on or something here when it's. And then after printing that, we can change even the color of the button to like say that it's on and that's off. And yeah, and then we can just like change the board dot LED dot state to on and off when we are like pressing and then releasing and things like that. Okay. So yeah, that will be LED dot on since we are still here. And then this part, we can wait again for the release and print another thing and then change the state to off. Okay. So yeah, we can just copy paste the code. So it will wait for not press, it will wait for release, and then it will just change the state of the LED. We can take the exact same code, copy paste, change this to on and off. So it will just like light the LED on when you're pressing and then just closing the LED when you're not pressing, like when you release the button. So that will be just off, and then here that will be off as well. Okay. So yeah, this needs to be capitalized for the sake of the state. So yeah, that's basically it. So that's how we just enable it, except when you press the button. So afterwards, we need to like input for our program, even like the frame numbers and number of objects that we wanted to detect, and like how many runs and stuff like that. That are the arg parts that we have been passing for the functions up there. So yeah, you can do that. Either you can input it, or there can be set to a default value. So also, just to save some time, because like the parsing statements are a lot, I'll just like copy paste it from the code that I've done before. And also, as I told you before, like the code, you could always find it in the description. And then I'll just explain what the parsing thing do exactly, like what does it parse and everything. So that's the first thing. Okay, so here. Now, so first we take like the parsing, and then first we are doing now the parsing for the phase detection. So for the phase detection, it just needs the number of frames. That's the only thing that you can pass for the phase detection model. And we just name it as argsf. So F is just for the phase. And then we'll have another parsing for the image classification camera example. So for this one, it can take the number of the frames, it can take the number of the objects, and it can also take like the enabling the camera and disabling the camera. Okay, and then also we're setting like default values. So for the frame numbers, it's always none. So it will always like be running forever. But still, like if you could remember that in our function, we made it stop after 2 seconds, so it's fine. And then the default thingy is for the object, it's just like for detecting 3 objects. That's the only thing that it can detect, like if nothing is entered. And then yeah, of course, that's the default also for the camera is always true. So that's for the arg parse part. And then now we should have like all the data. We just need to start building our own design of the attention checker. So first we need to create an instance of the Pi camera. And then to create that, I would also prefer to do it with the width. And then we just pass it the sensor model. And then we just pass it like the sensor model. And we pass it also the resolution. So let's just start by model. So I'll use 4. Okay. And then we'll have, after that, we need to pass it the resolution. The resolution, and then that would be equals to for us, I would just like go with 1640, and then with 1232. It's just like default values that are there. So yeah, that's fine. You could just like change that. And then the frame rate, we just need a good frame rate, so I'll use 30. Okay. So yeah, so the first thing we need first to start our camera preview so that it could like appear on the screen. So we just start preview. So that will just like put the camera, and after that we can increase the that's just like a relevancy thing. You can like increase the text size of the annotator, so it could be like more visible using the annotate underscore text underscore size. That's the only thing, and you can just pass it anything. So I might pass it 60. Okay. So yeah, it's up to you. You can just keep it the same. It's like keep it the default if you want. And yeah, we could just like take the input of the user first. Now we need to take the input for the study time that we're going to be passed to the function. And then we'll be like, for example, enter your study time, for example. And then we could just like say in minutes, because we want it in minutes. And we just do the operations accordingly. And then we take it as integer. You can keep it integer or whatsoever. I'll just cast it as integer for our reference. Like no one wants to study for 1.5 minutes or 5.5 minutes. And then it's up to you at the end. And then we just like, as I told you, we have to pass it for the function there in seconds, because the function time gets it in seconds. So I'll just multiply it by 60 now. And then yeah, we have it now in seconds. So then we can start with the exact thing. So as we said in our design, the first thing we want to do is that we want to detect if there is a face or not. If there is a face, we will start our attention checker. We'll start like the timer for the attention checker. So first we need just to do an if statement, and then we just need to call the face detection inference that we created up there and pass it the camera that we just created here for the Pi camera. So for that, yeah, I forgot here also to add as camera. Okay. Yeah, for that, I'll just pass the Pi camera that I just created up there. And then after passing the camera, I will also pass it the argsf. So that's for the face. And yeah, if this returns true, then it detected the face. Like if no, then it's just like output and just exit the whole thing. So yeah, that's for the first part. And then we can do a printing of like, I don't know, we can just like be like your face is detected, and then you will start the timing for the thing. So we can like, your face is detected, start studying for blah, blah, blah. And then just the time that we input. Yes, and then just the time that the user inputted or something. It's up to us like how to cast the whole thing, but this need to be string, of course, because this is integer and it won't display an integer. Okay, so yeah, so that's for the first part. Now we detected a face. Now we need to wait. So now we just need to start the loop for checking for the time. So I will do the while loop, and then it will just call the function, which is the duration is over. So let's see, what did we call it? Yeah, I don't want to like do it wrong. So let's go down there and just go here. And yeah, so while duration is not over, while duration over is true, we'll just like need to pass it x, which is the input of the user. So as long as it's not over yet, or the duration is not over, we need first, for my design, I'm going to make it sleep for 5 seconds. And then after that, it will check for the image. And then after that, it will recheck again for the face and stuff like that. So I will make it just sleep for 5 seconds first. And then it will call, after that, after the 5 seconds, it needs to call the image inference. And here also pass it the camera, and then the ARGS, but then now not the F, it's the S only. I think that's the one. Yeah, it's the S only. And then and then that will return a Boolean. So we can store that in a Boolean over here. So if you could remember, in the image detection, it will detect false if it doesn't find a phone, but if it found a phone, it will return true. So I'll just call, like, for the case of simplicity and like to remember what that is doing. So this, I'll call it like found phone or something. Okay. And then after like the found phone, we will sleep again for another 5 seconds. And we can do here an if statement. So let's just do this first, and then I'll show you what we can do after that. And yeah, we'll wait for another 5 seconds, and then we will again call the other thing. Now we'll call it found face. And yeah, for the other one, it will return true if it at least found one face, and then we'll call the face inference, the face detection inference. And we'll just pass it the camera and pass it the ARGSF, this one. So yeah, now it will just check each 5 seconds for the image, and then wait for another 5 seconds, and then check for the face, and that's it. But now we said that we want to do the summary at the end. We want to know like how many times did we did we got distracted, and also we want to like do an alert. So we need here to add a counter, for example, for maybe the phone, the number of times that we found the phone. So we can say phone detect, for example. Then we could just we can have this initialized at the beginning for the phone detect. Maybe we can initialize it here. Okay. And this will just count the number of times that we detected a phone. Okay. And then we'll do another one for the face. So that's the phase detect, and that's equals to 0 as well. And then we'll just like increment it each time we detect a phone. So each time we detect a phone, so if the found phone is equals to true, we detected a phone, then we will just increment the phone detect. So it will be plus equals 1. Okay. So, and after that, we will do, we need also to show an alert, okay? So yeah, let's just do the other if statement and then we'll write the function for the two. And then if here also, if we found face, we'll just do increment the face detect equals to plus equals to 1, okay? So yeah, that's the face detect. And then now we need to create an alert function or something that like lights up the buzzer and lights up the LED and then also fires the buzzer. So we can write another function that is called, it will be neater to implement it in a function, just call the function over here. So I'll just write another function called alert action, for example. And then just the alert action will literally just do nothing except that it will light an LED and then call the player that we created up there to play the music for the buzzer. So I need to create a LEDs. A LEDs is for the LED, okay, for lighting the LED as LED, for example, I'll just call it this way. Or LEDs, it's fine. And then after that, we need first, for my design, I will first do the LEDs and I will light it red. So to do that, we need to use the update function, and then inside it we have to do LEDs again .rgb to change the color to like the specific color that we want, and then on, and then we just pass it over here inside of the color, yes, dot red all caps. And yeah, that's the update function. And then after that, we just, maybe we can like print leave your phone or leave whatever you're, please focus or something, like just any message, please focus. And then we need to call here also the like the alert player that we have created up there. And then just to play it, we just call the play function. And it's so simple. Now we have it there, and then we can close the LED, like turn it off after we're done with all of that. So we could just here update, and then to turn it off, just exact same function, but here it's off. And then we just pass it empty brackets. So now we have the alert action, and that's just, as I said, lighting an LED, doing the buzzer thingy. So all we can do is that when we find a phone, we will be incrementing the counter for the phone, and then we will also be calling the function that we created up there. So the function is called alert action. So I'll just like call it, I'll not pass it anything because it doesn't take any parameters. And then I'll just call the exact same function again. If we, here it won't be if we found a face, it will be if we didn't find a face. So if it is not, then I'll just call the alert action and increment the thing as well, okay? So yeah, that's basically it for the loop. So yeah, that's it for the loop. We just need now to create the congratulation thingy. So this will just keep looping all over again. If you want, we can like, you can even do a print statement here that shows like the remaining time or something. So yeah, that can be done. And yeah, and you can even annotate it on the text, on the camera and everything like that. But that's basically it. So now when the duration is over, we want to type the code for like playing the congratulations song and like showing the summary. So maybe we can like first, of course, this should be outside the like the duration is over thingy. Okay, and then we just like print congratulations. Just ignore the spelling. Let's just go congrats. And then you complete it, for example, the time. blah, blah, blah. And then now we need to show the summary. So that will be easy to do since we already have the phone detection. So in my design, I just calculated it as if that the phone detection will be 5 seconds. So if the one phone detected, that will be 5 seconds. I'll just deduct 5 seconds. So it's up to you how harsh you want to be on yourself or something. So yeah, you could just like have it as, I'll just store it in the results thingy. And then inside that one, as I told you, I'll be deducting like 5 on each counter. So for like the result, which is like the most efficient time, I will like that the time that you actually spent on studying, it will be X, the time that you entered, minus 5 multiplied by that plus that, like this plus that. So it will be 5 multiplied by the phone underscore detect plus the face detect. Okay, so just like I took it as if like each one counter will be 5 seconds, and then after that I will just minus like all of that from the thing that I entered at the beginning. And then that could be it. Also, you could print even the effective time, like how many time did you spend on like you lost because your face was not detected, and which time is because your phone is not detected. So you could just be like maybe like you lost blah 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 minutes, something minutes, and then on because your face was not detected, your lost, oh, we can just like you lost blah 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 minutes, and then that's like the result, and just keep it in a string, and then inside that would be the result that we just did, and then we just like make it divided by 60 because this one is in seconds, so we need to divide it by 60 first, and then we can do it, we can round it or something, it's up to you, but yeah, let's keep it this way. And then you can now specify like the exact timings for each. So you can say you lost blah, blah, blah minutes plus minutes as your face was not detected, for example. So that's for the face detection. So for the face detection, we'll just like, we can do it outside or we can do it here, it's up to us. And we can just like multiply the things up there. We have the number of faces. So I have to do like the operation of like multiplying 5 multiplied by the face detection. That's the number that the face were not detected. Now you need, sorry, there is nothing here. And then after like multiplying, now you have each 5 seconds. And then after that you need to multiply to. So yeah, that's basically it. You can divide it by 60 now because that's in seconds. You can divide it by 60. Sorry. And also you can have all of that in a string. str. You can round it as well. You can round all of those as you want. But yeah, I'll just keep it this way. Yes. Yeah, as your face was not detected and you wasted blah blah blah. Here we'll write the blah 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 plus you were using the phone. Okay. Yes, yeah, that's it. And then here for, of course, this will be phone rather than the face. And yes, it will be the exact same thing, just the string and then the output. So now we have the summary printed off for the user. And you could even play around more than that in the summary. You have everything, you have the counter, you can just like edit it whatever way you want. And yeah, you can round it as we said. So basically, that's it. We just, one last thing that we need to do here is that we need to call the player for the congratulations song that we just input it up there so it just could play like the song and the congratulating thingy for the user. So that would be like play and just this way. And yeah, that's it. You can just, now you can do for this if statement and else as well, for like the sake of efficiency, because I forgot to do that. We can put it now. So this is an else for like the face was not detected. Maybe you could just like print your face is not there. No face detected to start. No face detected. So yes, just like anything, just for the sake of like knowing what's going on. And yeah, that's basically it. You printed the output, you printed the summary, and then you played the song for the player. You could even like light the LED again here, but yeah, it's really up to you, like what you want to do. But the only thing I'm doing here is just printing the summary and also playing the congratulations song. And you could even do that on the annotator text as well. Okay. And yeah, one last thing is we need to close the camera preview. So let's just see, where did we open it exactly? So just we opened it inside the width. Okay. So we'll close it here. So camera preview. Camera.stop preview. So we need to stop the preview of the camera. And yeah, that's basically it. We just need to call the main. And just call the main. And that's basically it. We have finished. So let's go on and like I will show you the output of the code. So I call the file that I'm using here test attention checker. Okay. So let's just call the test attention. So now it will start. So once the camera is up, we should start, like it should first displays the output that we need to press the button. So we'll first press the button. We can now see the camera over there, and we can even see on the console that it's like asking us for the study time. So just for the sake of trial, I will enter 2. And now it needs to detect my face. It detected my face. So now it's activated. The time is activated. It's waiting for 5 seconds, and then it'll start looking for things in the background. So first here it's detecting images. There's no images out there. So like it didn't detect any phone, so nothing, no bill, and no back, and no like light or anything. And now it's detecting for the face again for the thing. And if like I just removed my face from the frame, you would, now there is a noise. And then now that's the congratulation thing, because like the whole thing ended, and because like the 2 minutes ended. And yeah, you can see now the summary over here, like the effective time of study, it's 1.9 minutes out of 2 minutes, because we wasted some time on our face was not detected, which is 0.08 minutes. And then we have 0 minutes wasted on the phone, because like I didn't like try the phone. So yeah, that's our attention checker. Thank you so much everyone for watching. Hope you enjoyed the workshop, and you could also go to our YouTube channel and subscribe on the channel for more informative workshops like that. And yeah, stay tuned for other informative workshops. Thank you for watching.